Right, so today we're going to be dealing with statistics 3. We're going to be talking about measures of dispersion, right? As I was saying, statistics is a huge topic, and even though when you take it in small doses, you can see it's actually a really easy topic, right? Right. So we're talking about a frequency polygon. And you all I hope you all remember what a frequency polygon looked like, right? Essentially, what we have on this side, we have the marks from 1 to 10. And over here, we have the frequency of students, right? So we could see here that one student got 1 mark. 10 students got 6 out of 10. Right? We could see here that the largest amount of students, like 9 students, got 5 out of 10. 8 students got 7 out of 10, right? So the largest amount of students always kind of ends up in the middle. And the further you go out from the middle is the lesser and lesser it gets, right? So I just kind of want you to notice that, yeah? Now, we also spoke about things like when we're dealing with a frequency distribution, how to find your median and your mode and your mean, and what are the differences between the median, the mode, and the mean. So we'll be looking into that a little bit more today, right? Now, in a frequency distribution, of course, you know, we plot the polygon. So we could see here that just what we were talking about, how all of these larger numbers was kind of more around the middle, right? And if we look at it here, we have the marks and the frequency always goes on the vertical axis. And we have this huge bump in the middle, right? Where we have the most amount of students, 10 students getting around six marks, right? So we could see here, we could tell from this graph that of this entire class, and we know that we need to add up the frequencies because these are numbers of students. That is what the frequency is. So when we add that up, we'll get 50 students, right? The marks for 50 students. So out of 50 students, you have the majority of the class making in the middle marks, you know. You also have some of the class, a little bit of the class making in the high 9 and 10, and you also have a little bit of the class making very bad, less than 4, less than 3, right? So we can actually tell a lot of stuff. Now, one of the things we're going to do is we're going to go today from a frequency polygon to a frequency curve. Because what people realized is that, yeah, I have this point here, and I have this point here, and I have this point here, and I have this point here. And to make a frequency polygon, we just connect them with straight lines. But instead of connecting them with straight lines, let's just kind of approximate a curve. And the curve is just an approximation, really, right? But we'll approximate a curve and we'll get something looking kind of like this. We call it a bell-shaped curve, and we'll talk about that a little more in the future, right? So what they found is that no matter what kind of data that you was getting, no matter what is the data, this is the data of marks and students, right? If you're dealing with data of, say, cows and grass, right? Or you're dealing with data pertaining to, I don't know, shoes and shoe sizes, or you're dealing with data of fleas on a cat, you know, the average amount of fleas that could be on any cat, you know. No matter what is the kind of data that you're dealing with, oddly enough, what we found is that when you put a frequency table and you plot a frequency curve, you're going to get a bell-shaped curve like this, right? Where you will have the majority, you know, getting average marks, essentially. You'll have a small amount doing exceptionally well, and you'll have a small amount doing exceptionally bad, yeah? So this bell-shaped curve has become a very famous thing, yeah? So we're talking about the bell-shaped curve and the frequency curve. And you can see here that we have a frequency histogram. And the histogram is the bar column looking thing where all of these bars are joined. Just reminding you guys, right? And, you know, you plot your marks against the frequency, your students or whatever, right? And in order to do, and I'm just reminding you, we did all this already, but in order to plot the frequency polygon, you had to take the midpoint of each one of these bars. So it's the same thing with the curve, right? We just kind of approximating a curve. The curve is really just an approximation, yeah? And what we find is that all sorts of data, no matter what data you're dealing with, kind of falls when you do a frequency distribution. It falls in this curve. It's the bell curve or the frequency curve. And there are three types. You have the normal curve, which looks just like this. You have the positive curve, and you have the negative curve, right? So we'll take a look at these three curves this evening, especially for those of you guys who are into business. I know I have a couple of accountants in the house. So so this is really, really handy information, understanding these basic statistics, right? Right? So moving on. So we're talking about the normal curve here, right? And in the normal curve, as I say, our example is dealing with the marks. These are marks from 1 to 100, right? So the marks are out of 100, and these are the amount of students, the frequency of students, and if we add all of this up, you'll see that we pretty much have 100 students in this sample, is what we call it, right? And this is pretty much your average frequency curve. And when you plot this, and you can see it here, the middle from like, say, the 40s to the 60s, you have, you know, even the 30s, you have the largest amount of students, and it gets lesser and lesser as we go to the outliers, right? And we call these guys the outliers, which is a term that we use, maybe not for CSEC, but it's a little bit of an advanced term, right? So you could see here that we have the normal curve here, and you have the majority of the students making in these very average marks, just around the pass mark, maybe a little higher, maybe a little lower. And I could tell you for sure that this curve would also describe CSEC people, right? So CSEC people who write in CSEC math, for example, you would have the majority of students coming in this little zone here, making just above the pass and just below the pass. You'll have the majority of students. You'll have the very few exceptional ones who getting all the way up here, right? Close to the maximum 100. And then you'll have the very few who making closer to 0 on this side over here. So we're dealing with the frequency curve, and this is the range here. The range, and we'll talk about a little bit more about the range later on. But this range here is basically all the marks from, 0 to 100, right? Now, please keep in mind that the range does not always have to start at 0. And when we talk a little bit more about the range, we'll see why, right? So we have our range there, and what we'll remember, and if we remember about it, we have this line in the middle that cutting the range exactly in half. And that line we had called the median. Remember, the median was the value right in the middle. The median was also called Q2, right? And we'll see why it was called Q2 in a minute, right? So what you'll see in a normal curve is that the median goes right down the middle. So if we are saying here that this is 50 out of 100, and we could see here that around the 50-60 area, the 50 to 60 area, we have 24 people. So this is a maximum frequency here of 24 students making in this area over here, right? We can see here that we could use the median to answer that question. Well, what mark does most of the students make? You know, most of the students made around 50 to 60, the biggest group of students. Yeah, we could use the median to tell us that information when the curve is normal, right? When the curve is normal, you'll realize that the mode, if you remember what mode is, can anybody remind me what the mode is? Let me get some class interaction here now. Right, so we could see here, it's the most popular. It's the most popular. So what is the most popular? Just look at it right here, 24. 24 is the mode. 24 has the highest frequency. It occurs the most. So therefore the mode here is 50 to 60 marks, right? That is the mode. So from the mode now, this also happens to be your median. Your median actually might fall in that bracket as well in a normal curve. So in a normal curve, when you work out what the median is, the median will fall somewhere in there. That is the mark that is smack in the middle of your range, right? So the median is the one that's in the middle, right? The mode is the one that is the most popular, is the one that has the highest frequency, right? And the mean is the arithmetic average. We just actually use a formula to work out the mean. Yeah, the mean, in order to work out the mean, I would have to go and write out the individual marks of all of these 100 students, right? And then I would have to add up all of these marks and divide it by 100 students, and that would have given me the mean. And what we see in a normal curve is that the mean, the median, and the mode all lie on this middle line, right? So in terms of, if you are dealing with a piece of data, if you are doing research to find out on shoe sizes or the fleas of a cat or students, right? You could use your mean, your median, or your mode to get a good reflection as to what is the highest frequency that you'll be dealing with, right? Now, this is an important thing to understand, and we'll see why now, right? Because now you can have something with a positive skew, right? Now, if you look at it, a positive skew here, just remember if we were dealing with the marks of students, right? So these the amount of students that get closer to 0. These the amount of students that get closer to 100. Now, can you look at this positive skewed curve? Because this is a class of, let me just say, is a class of 100, right? What can you tell me about this class? Yeah. You could see that. You could see that most of your students here, most of these students here did very, very bad. Yeah, most of these students here make less than 50%. So a positive skew curve, you could think of it as kind of like a bad thing. Right? You'll have, and it depends on what you're measuring too, so it might not necessarily be a bad thing, but you'll find that the positive skew curve it's slanted more towards the 0. Yeah, it's slanted more towards the 0. Sometimes that could be a good thing, sometimes it could be a bad thing. It depends on what you are researching. So this is a really interesting thing to look at, that most of this class, so you could look at a huge amount of data. When Anthony Garcia get the marks for all of Trinidad and Tobago for CSEC maths, right? It's not like he's a man going to sit down and look at all of the marks. No, they are going to show him a curve like this. And he could see, if he sees a positively skewed curve, he could say, well, here now, most of our students doing real bad. So we had to change something, you know? So you could see how a curve like this is important when it comes to making decisions in life, yeah? Now you could tell something, right? When it comes to, you know, what is the highest frequency? Because we see here that this mark here, whatever mark this is, it looked like somewhere around 25 maybe, right? The highest frequency of students here, right, made around 25, right? So if it is Anthony Garcia wanted to find out, well, you know, how much most of the students make. Most of the students make around 25, right? You can tell that the median, remember the median is the line that cuts your range in half. It's the piece of data that is smack in the middle. So you can tell that your median is not a good measure, right? When you have a positive skew curve and you want to find out, well, how good did most of the students do? What mark did most of the students get? You don't want to take your median. Your median is not going to give you an accurate answer, right? You don't want to take your mean either, because when it is you add up all of the marks of all of the people in Trinidad and Tobago and you divide it by the amount of kids that sit the exam, your mean is going to fall on the right side of your median, right? Statistically. So the mean in a positive skew curve is not going to be a very good idea either. But what you find is that the mode will give you a good estimate as to the highest frequency of students that you're dealing with. So I want you guys to make a note of this, even if you just had to sketch this curve, right? Where the median is, the median will always be in the middle. The mode is the guy that will always have the highest frequency. So the mode will always be under that highest point there, right? And the mean will always be on the other side of the median. Yeah, so your mean will be somewhere up there. So you can see here that the mean and the median, they're not too good. You could throw away that. The mode is what will give you the more accurate information here, depending on what you're looking for. Now, of course, with a negative skew curve, what can you say about this class? Look at where the highest frequency is. This is the highest frequency, so the most amount of students here, right? So the most amount of students is here, right? And where is this falling? This is falling up here. This is where my marks are. So my marks will be from 0 to 100 in this case. Yeah? So maybe you're seeing that the highest frequency of students out of 100 students, let me just say 30 students, right? Which is the biggest group. The biggest group making somewhere around 75, right? Yeah? We have a whole set of people who making approaching 100. Yeah? We have a whole set of people. Look at where the 50 mark is. If this is the 50 mark, right? The majority of the class passed the exam here, right? And then we have a lower frequency, right? This lower frequency of people would have failed the exam or gotten under 50. So you can see here that whilst the positive curve was not a very smart class, this negative skew curve is a very smart class, right? And the negative skew curve is the one that leaning away from the zero, closer to the maximum, yeah? That is how your negatively skewed curve will lean, right? Now, we could see here that in a negatively skewed curve, the median, which is the very center of the range, is still not a very good estimate as to how well the students did, you know? And we could see here that the mean or the average, the arithmetic average, isn't a very good estimate either of how well the students did, right? But the mode, so with positive and negative skews, the mode is the one that gives us a little bit better of an idea as to how well the students did in terms of the largest group of students and what mark that they made. So the mode here tells us that the largest group of students here made around 75 out of 100. Now we have some of these comparisons here, and you don't have to write it down. Remember, I'll be posting a video up, so you could always just pause the video and write it down. But what we were talking about just now, yeah, this is just a little bit of a comparison of it. In terms of the mean, the median, and the mode, we saw, well, generally the mean is the most commonly used because, you know, people go always ask you, well, what is the average price? Or where's the average temperature? Or where's the average, you know, whatever, right? People will always ask you about an average. So people are always asking you about the mean, right? The median is something that's always consistent. So it'll always give you that middle mark. So if it is you're looking for something that is in the middle, the median is the way to go, right? And of course, the mode is very simple to understand. Now, you can just read through this. It's not like you have to memorize it or anything. But understanding is the most important thing here. For example, the mean is the thing that one of the advantages of the mean, the average, is that it could be calculated exactly, right? The median and the mode are not generally calculated exactly. You just read the mode off of the graph, or you could read the mode off of the table, right? In terms of a mean, you could see that the mean is best to use if you have a normal distribution. But the mode is best to use if you have any skew taking place, whether it's a positive skew or a negative skew. So when you look at the video, take a look at this, give this a read. It's just a nice little piece of understanding that you should have, right? Now we actually getting into measures of dispersion. Right, and as I say, we're not going to take too long with this class today because we still have the past paper to take a look at. So measures of dispersion, we're first going to talk about the range. Now we could see here the range, you know, we was talking about the range being from 0 marks to 100 marks. So that range spanning 100 there, yeah? But the range does not always have to start at 0, right? So let's just see here. We could see here that this range certainly doesn't start at 0. What we have here, we have the basic wages for workers in a factory. How much workers we dealing with? 1, 2, 3, 4, 5, 6, 7. And we have the basic wages for these workers, right? So calculate the range, right? Now the range in this case is really, really simple. It's just the largest value minus the smallest value, right? So the first thing that we have to do is we have to arrange this in ascending order. And it's always good when you're analyzing to sort your data in ascending or descending order, right? So somebody, real quick, arrange this in ascending order for me. What I have here, 148 first, and then what? 149. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yep, that should be it, right? So now that we've arranged it, we can easily see what is the largest number, what is the smallest number, right? In terms of the frequency distribution curve, you could tell that the smallest number is $148, right? So this range certainly does not start at 0. It starts at 148 and it gets as high as 195. So what is the actual range? Well, it's the largest number, which is 195. So the range is 195 minus the smallest number, which is 148. And let me just grab my calculator, unless somebody could do it quicker. 195 minus 148 is 47. So the range here is $47. So the range of wage differences that you are paying your workers is around $47, you know? So yeah, does everybody understand? Now please remember that this is raw data. We were actually given these values here. These are values like if you go and you ask 7 workers, hey, how much you getting paid? How much you getting paid? How much you getting paid? This is the raw data that we get in here. We ain't put this in no frequency distribution or nothing, right? So this is the raw data that we are getting here, and from raw data, you just take your largest number and minus the smallest number, and boom, that is your range, right? So this range here spans $47. That is the range. Now, as I was saying, this is when we're dealing with raw data. But what about if we're dealing with a frequency distribution? Now, I want you to notice, CSEC is only going to ask you for an ungrouped frequency distribution. So ungrouped, remember you have the grouped. The grouped would be if you have, like, say 1 to 10, and then 11 to 20, and then 21. So that is grouped, right? So grouped data, CSEC will not ask you for that. CSEC is going to ask you for ungrouped data. So what we have here are the mass of 50 lambs. So this frequency here is the number of lambs. And we weigh in these lambs because we want to sell them. And of course, the heavier a lamb's weigh is the more money that we'll make on it. So I want to know how much money I'm going to get from the total of 50 lambs that are weighing, right? I would love to have a negative skew. If I had a negative skew and all of my lambs, all 50 lambs were weighing 33 kilograms, then I would be smiling and nice. But it seems to me a pretty normal thing, because the largest amount of my lambs are weighing somewhere in the middle. So it looks like a normal kind of situation, normal curve, right? Now, of course, these are the frequencies, so if I add up all of these frequencies, I will get 50 lambs. Now, when we're dealing with a frequency distribution, right, how do we calculate the range? Well, with a frequency distribution, we have to look at the boundaries, right? We actually have to look at the boundaries. So if somebody remembers anything about boundaries, right? We're looking at this 27 here being the lowest or the smallest number, and we're looking at this 33 here being the largest number. And you know that when we're talking about range, you just minus the largest number and you minus the smallest number from the largest number, and boom, you're good to go, right? But that is for when you're dealing with raw data, not a frequency distribution. A frequency distribution, you have to take the largest boundary and minus the smallest boundary. So anybody remember what boundaries are about? And could somebody see if they could figure out what is the largest boundary and what is the smallest boundary? The smallest boundary, if we look at the smallest number is 27, right? So 27 now, the smaller boundary would be 0.5 right before that. So that would be what? 26.5. And that would be the boundary that happening right before the 27, 26.5. And the largest boundary will be the boundary that happening right after the 33. So 33.5, right? So I have here the range being 33.5 minus 26.5. 33.5 minus 26.5, and that is 7 kilograms. So on my frequency curve, this range here is spanning a range of 7 kilograms. And you will notice that it doesn't start at 0. It actually starts at the 27 here, and it actually finishes at the 33 here, right? Now you can see that this range here is pretty much almost like raw data, where you're just minusing the largest and the smallest. But when we're dealing with a frequency distribution, please remember you're using the boundary, right? The boundary, it'll make a little bit of a difference, right? So everybody cool with this? Any questions? No? All right. I hope you're all making your notes. Yeah? Thank you very much. All you know that the quicker all you say something is the quicker we just move on, right? So I don't know if you all figured that out by now. Nice. So what we're going to talk about here, we just spoke about the range, and we saw that the range was spanning from the minimum value straight up to the maximum value. And that is the full span of the range, right? But what we're going to talk about here now is something called interquartile and semi-quartile range, right? So it's a part of the range now, and you know quartile. Look at the word quartile, right? It reminds you of the word quarter, yeah? So just keep a mind on that, yeah? So remember here I have the median, and we had called the median Q2, right? So Q2 is the second quartile. That is what Q is for. Q is for quartile, right? So we have here obviously Q1, and we have here Q3. These are my quartiles, right? These lines here, 3 of them, are my quartiles because they divide the entire thing up into 4 parts, right? So the entire frequency distribution curve is divided into 4 parts by these 3 quartiles, right? You have the lower quartile, which is about a quarter of the range, and you can see it here. This, you know, if you're going from 0 to 100, this could be about 25, right? Yeah, a quarter of the range, right? The middle quartile, which is also known as the median. So the median is that middle quartile at 50 out of 100. And the upper quartile, Q3, would be at 75 out of 100. Now, you saw that when we were dealing with a range, you had to use your maximum value minus your minimum value, and that gives you the range. Well, the interquartile range is when you take this Q3 value over here and you minus the Q1 value over here. That is the interquartile range, right? Now, the interquartile range is something very, very important, because you could see here that if I was to take this 75 from this line, right, and I was to minus everything under this line here, what I would be left with is this area over here. So your interquartile range is that range where most of the students landed in this area. Yeah, you could see here that only a little bit of the students making above 75. Only a little bit of the students making below 25. Most of your students are inside this interquartile range. So the interquartile range is something that's really, really super important, right? So then you also have, and of course the interquartile range in this case would simply be 75, which is the Q3, minus 25. So the interquartile range in this case, 75 minus 25 is 50. Yeah. The semi-interquartile range is if you take the interquartile range, which is Q3 minus Q1, and you divide it by 2. What you're actually doing is you're taking this area, right, and you cutting this area in half. So you're cutting out these guys, and now you're just dealing with this highest concentration area in the middle here. This high concentration area from this line to this line is what happens when you cut your interquartile range in half. So the semi-interquartile range is really just focusing on the highest central zone over here. Now the interquartile range from raw data, right? So we're talking about raw data here. Remember the interquartile range, if we have the frequency distribution, this is the median in the middle, Q2, right? And I have here Q3, and I have here Q1. Oh, there's one more thing I wanted to say though, right? Yeah, you could think about the lower quartile as 25% or a quarter. You could think about Q2 as a half. You could think about Q3 as 3/4, right? But it's not as simple to just go and find 75% or 3/4 of the range. You can't just go and find a half of the range. Why can't you? Because remember, the range don't always start at 0. Yeah? So it's not like you could just go and do that. No, the range could start anywhere, from anywhere to anywhere. Yeah? So we'll see how we actually going to find the range, the interquartile range, the semi-interquartile range from different types of data. So when we're dealing with the raw data here, let's just take a look at this. We're dealing with the mass of these lambs here, right? And I don't really care about the frequency of people and things. We're not talking about that. We're talking about the range, right? So the range is normally calculated, the x-axis, this horizontal axis here, is what we're dealing with. And in this case, is mass. Because remember, this axis is always frequency. So we're not talking about the frequency. We just want to deal with the range right now. So first thing I want to do is I want to state the quartiles. So I have the quartiles Q1, Q2, and Q3. So I want to state the quartiles, and hence I want to find the interquartile range. Now in terms of CSEC, it have no special formula to do this. You literally just have to eyeball this. Yeah, at the CSEC level, you literally just have to look at the table. And remember, let me see if anybody could remember, right? The easiest thing here to find is Q2. So Q2 is also known as the median. Can anybody look at this table and tell me what the median is? Right, the median is the one in the middle. Thank you very much. Look at how much guys we have here. Look at how much guys we have. 1, 2, 3, 4, 5, 6, 7. So remember, we're dealing with 7 data points, 7 data sets, 7 rankings, right? Ranks of data. And because we're dealing with an odd number, then it's easy to see the median being the one smack in the middle. Look, I have 3 data sets on this side, 3 data sets on this side. So the median is smack in the middle there. So I could see now that my Q2 is just simply 30. 30 being the one in the middle. All right. Now, if I want to find Q1, Q1 is the lower. Q3 is the higher one. So Q1 gonna be somewhere here. Q3 gonna be somewhere here. Right? Can anybody make an educated guess as to what Q1 and Q3 might be? So we could see here that Q2, if you look at Q2, Q2 is in the middle of your entire range, right? Right. But look at Q1. Q1 is in the middle. If you look at this half, right? Q1 is in the middle of that half, right? That's the quarter mark, right? And then if you look at this half, Q3 is in the middle of this half, right? That's your 3/4 mark. Yeah? So if I look at this half, I could see that this guy is in the middle of this half. So that is my Q1. Q1 is 28, right? And if I look at this half, the higher half, I can see 32 is in the middle of the higher half. So 32 is my Q3, right? So Q2 is the one in the middle, right? And let me just write it over a little neater. Q2, all right, I'll do it in order. Q1 is equal to 28. Q2 is equal to 30. Q3 is equal to 33. No, 32, sorry. Crap. 32. Yeah. Now we could see why Q2 is smack in the middle. It's an odd number, right? And then if we look at this half here, Q1 is smack in the middle. And if we look at this half here, Q3 is smack in the middle. So now I have Q1, Q2, and Q3, and I know my interquartile range is just simply Q3 minus Q1, which is 32 minus 28, which is what, 4? Yeah. So that is my interquartile range, 4 kilograms. So we can see here that the full range we had calculated at 7 kilograms. And the interquartile range, Q3 to Q1, this span here, the majority of lambs are in this 4 kilogram span range here, right? Now I have another question. Remember, this data set here was an odd number. And with the odd number, it was easy to find the guy in the middle. And with the odd number, it was, easy to find these guys in the middle of that. But what if we're dealing with an even number, right? So an even number of data sets, an even number of ranks. I have 8 ranks here. When I'm dealing with an even number of data, can anybody remember how I find my median, Q2? 30 plus 31 and divide by 2. That is what I'm supposed to do, right? So 30 plus 31 divide by 2 is 30.5. So in this case, my Q2 is 30.5, right? Now, we could tell that the 30.5's lying smack right here in the middle. Yeah? It lying right here in the middle, right? I have the 30 on this side and I have the 30 on this side, and this is my halfway mark. So if this is my halfway mark, that means I have an even number of data in this half, and I have an even number of data in this half. So how am I going to find my Q1 and my Q3? Any critical thinkers in the house? Think about it just like the median. I take this half, right? And I look at where's the middle number here. And with this half, it was easy to see 28 in the middle. But with this half, I have 2 values here in the middle. So I'll take them 2 values for Q1 and I'll add them. Same thing like the median, 28 plus 29, and I'll divide it by 2. And that'll give me 28.5. Right? And can anybody tell me what Q3 is going to be? Ah, nice, lovely. Right? So what I did was I take this half from the 31 and I come down here. I realize it's 4 numbers. So I take the 2 numbers in the middle. Right? That is where my Q3 is supposed to be. And I add them, 32 plus 33 divided by 2. And that gives me 32.5. Right? Therefore, my interquartile range is going to be equal to Q3 minus Q1, which is 32.5 minus 28.5, and I believe that still gives us 4. Let me just check and make sure. 32.5 minus 28.5 is 4, yes. Right, so in dealing with measures of dispersion, the interquartile range and the semi-interquartile range, now what we were just talking about, raw data. So raw data, that was just the mass alone. We ain't really considered nothing with frequencies, right? But now we're going to deal with how to find your interquartile and semi-interquartile range from ungrouped. So we're not dealing with grouped data for CSEC, okay? For CSEC, we are just dealing with ungrouped data from an ungrouped frequency distribution. All right? So first thing is first, when you're dealing with interquartile and semi-interquartile range, and you have a frequency, the first thing you have to do is to construct a cumulative frequency table. So, can anybody complete this cumulative frequency table for me? Thank you very much. It'll be 3, right? Now, remember cumulative. So, if we now dealing with anything less than 28, that'll be this 9 plus this 3. So 9, 10, 11, 12. So the 12 is going to go over here for whoever said 12 just now, right? So you understand, we started with the lowest value because it didn't have nothing to add to, yeah? But now when we go up now, the 9 added to the 3, so that'll give me 12. Now, any lambs that are less than 29, so that'll be 12 plus 16, which is what? I'll finish it for me now, come. I can't be doing all the work. So that's 16 plus the 12, right? And now the 13 plus the 28 is? And then 5 plus 41. And then 46 and 2 is 48. And that plus 1 is 49. And then plus 1 is 50. When you're doing a cumulative frequency, you remember that the last value is your total. So we could see here that we are dealing with 50 lambs, right? And all of this talk about lambs kind of getting me hungry, actually. And now we are going to deal with finding the quartiles. Now, we already know how to find one of the quartiles. We did it in the last class. It had a formula that we used to find the median from a frequency distribution. Right? So, in this case, we had a half n plus 1, and that would give us Q2. So, obviously, I think that you could agree that we would get a Q1 if we did a quarter of n plus 1, and we would do we would get Q3 if we did 3/4 of n plus 1. So this is how we find our quartiles when we are dealing with a frequency distribution. Right? Now, can anybody remember how we actually found the median using this formula? It was a bit of a procedure. Anybody want to remind me, what do I have to do next? Let's just find Q2 first. So what do I have to do next? All right. So I will put for Q2, I will put a half n, which is 50, plus 1. And remember, this not actually giving me the median. This just giving me the rank that the median is in. Right? So a half of 50 plus 1 is a half of 51. So 51 divided by 2. That gives me 25.5. So it is telling me that the median, remember 50 is the frequency. So the frequency we was dealing with people. Well, in this case it wasn't people, it was lambs. Sorry, lambs. All right, or students. And some people would agree that students are lambs, if you listen to Pink Floyd at all. I don't know if you all know who Pink Floyd is. But, so we got here 25.5 lambs, right? That means that the median is basically, you can't have 25.5 lambs. So the median is lying between the 25th lamb, the TH ranking, and the 26th lamb. That is where the median is lying. And we did all of this last class, right? So we use the formula to find the rank. And the rank is between the 25th and the 26th. So let's go to our table here. And can somebody tell me, well, we can see here that the 25th lamb is going to be here in the 28th zone here, right? This is where the 25th lamb is going to be, right? And the 26th lamb is also going to be in this zone here. So now we could look across here and see 29 being our Q2. So therefore Q2 is equal to 29 kilograms, right? How are you feeling about this? This is something that we did last class. Now one person feeling good, everybody else feeling horrible. All right, so if you guys understand so well, guess what? It's the same exact procedure for Q1 and Q3. So take 5 minutes and work out Q1 and Q3 for me. Right, so for Q1, we could see here that we come up with 12.75 lambs, right? You can't have 12.75 lambs. So that means that Q1 lies somewhere between the 12th lamb and the 13th lamb. Yeah, so that is where 12.75 will lie, between the 12th lamb and the 13th lamb. So if we look at it here, the 12th lamb is lining up inside of here. This is number 12, and so the 12th lamb is actually the last guy in this group, right? And he will be clocking in at 28. Yeah, so the 12th lamb is clocking in at 20. So whose microphone is on? Somebody want to say something? Right. So the 12th lamb lies inside of here, but the 13th lamb will be in this group, right? Because this group here finishes at 12, right? So the 13th lamb will be inside of this group, which is in the 29. Yeah? So the Q1 now, it has two values here. The 12th lamb is equal to 28 kilograms. And then the 13th lamb is in this group. The 13th lamb wouldn't be in here. No, because this is up to 12. So the 13th lamb is the next one. He falls in this group. And this group is the group with 29. So the 13th lamb falls in the group with 29 kilograms. So when you have two values, you do what you do. That'll be 28 plus 29 divided by 2, which is 28.5 kilograms, I believe. Yeah? So can anybody put me through, use that same logic and tell me what's going on with Q3? So this value gave us 38.25. This, nope, that's not it either. All right. Remember, this is 38.25, right? You can't have, we're talking about lambs. You can't have a 38.25 lambs. You could either have 38 or 39. So we could see here that this Q3 value lies between the 38th lamb and the 39th lamb, because that is where you'll find 38.25. So we looked at this value here to tell us which lambs in the rank we're dealing with. We're dealing with the 38th lamb and the 39th lamb. Alright? So that is where Q3 lies. It lies between the 38th and the 39th lamb. So we have to go now and see where these lambs are in the table. If we look for the 38th lamb, well, he gonna have to exist somewhere inside of this group, because this last group here ends at 28, so he wouldn't be in there. And this group here ends at 41, so he'll have to be somewhere in here. If we look at where the 39th guy is, the 39th guy will have to be inside of the same group. So just like the Q2, we find that with Q3, the two lambs are inside of the same group. So we could just read this one reading here, 30. So Q3 is at the 30 kilogram mark. So what we did, and we did this last class, so we just applied this formula here, right? First, we found the cumulative frequency in order to get the total at the end. Not just to get the total, but we needed all of the guys lined up in a ranking kind of way, you know? So, once we have the total, we use that as n, and that gives us the ranking over here. The ranking of this is value here that we got 25.5. That is not Q2, you know. That is not Q2. That is where we will find Q2. But this 25.5, well, it can't be possible because I'm dealing with lambs or I'm dealing with people. So it could either be 25 or 26. So this 25.5 lies between the 25th lamb and the 26th lamb. So what I needed to do here was I needed to go and see where the 25th and the 26th lambs lie. So when I go here now, I could see that, well, this group here is up to the 12th lamb. And from 12 to 28 is this group here. So my 25th and my 26th guy going to be lying inside of this group here. So I got one simple number, 29 kilograms. In this case here, right, when we worked out Q1, we saw 12.75. Well, that lies between the 12th lamb and the 13th lamb. So I went and I saw where the 12th and the 13th lamb was. The 12th lamb is actually the last lamb in this group, right? The 13th lamb, it'll be the first lamb in the next group. So I'll have to use the values from both groups, right? So this group with the 12th lamb had a value of 28 kilograms. The group with the 13th lamb had a value of 29 kilograms. And so I was able to get my Q1 by adding them and dividing by 2 to get 28.5 kilograms. And now, of course, we could just easily, and I wouldn't even bother, but we could easily just go and work out the interquartile range by just saying Q3 minus Q1. And we could also easily go and work out the semi-interquartile range by just saying Q3 minus Q1 divided by 2. The hardest thing here is actually getting the quartiles.